What we're going to do now, that's still the intricate stuff, the lower energy stuff. We're going to go through to the shell site, which is just over here in the coach park, because this is the higher energy, higher altitude fireworks. That stuff down there is the kind of the fiddly, intricate stuff at very, very steep angles.
Which is your favourite to work on?
Oh, both. You can't have a show with one and not the other.
Pick favourites.
No, you can't. I mean, there's a lot of the kind of fiddly stuff, if you like, that I like to do down there. But you need to sort of finish it off with the really high altitude stuff in the air as well. And I
Is
think
that more impressive than you think?
They can be. They can be a bit more sort of the crowd pleasers. Certainly when a shell lifts, you get this kind of muffled kind of whoosh, and everyone sort of looks up expecting to see something. A little bit more difficult on a show like this. They don't always hear the lifts because this is a musical show. So yeah, they can be the crowd pleasers, but it's the play, it's the contrast between the really high altitude stuff and the low altitude stuff as well. If you've just got stuff in the air all the time, really high, it actually gets quite boring.
Yeah.
You need to bring the show back down to the bottom. So there's actually quite a lot of psychology in a fireworks
design
show.
and art
design
and
art as
everything.
well. And that's the thing. So we're using engineering and science, technology and maths. But actually we use it, I'm just watching because we're crossing the road here. This is probably not good, is it, filming on the road?
Resume in a minute?
I think we'll start again the other side of the road. You see, as we wander around, you find little bits of fireworks. That was a falling leaf effect. So that was probably from one of last night's shows. And that is a little bit, a tiny, tiny fragment of shell casing. So one of the big aerial bursts.
So what's different about where we've come now then? How are these fireworks any different to the ones we were looking at before?
Well, one of the biggest differences here, of course, is the fact that we're on tarmac. So it's a much firmer base that we're standing on. No grass here, although we could do it on grass. But this really is, it's like, I don't like to use the term, it's like the big boys of the fireworks. It's the big fireworks, the larger calibre fireworks, much higher energy, much higher altitude. These are the things that are going to create the big shapes in the sky, so the highest effects that you see in the sky. And so we're actually setting them off further away from the audience, just in case something goes wrong. Sometimes we get ground explosions, sometimes the fireworks go off on the ground, so we need to calculate what's the distance that the stars and the effects could potentially go, and all the debris and shrapnel, if it did go off on the ground. So we keep these fireworks much further away from the crowd. Now, that said, the majority of these fireworks will go off absolutely trouble-free, but on last night's show, for example, I saw two ground explosions, and it's just, you know, that's why we've got them. So these are the mortars, the tubes in which we put the aerial shells, those really high effects I've been talking about. And you can see that we've got them at different angles. Each tube has got one firework in, and you can see how you know, the tubes are going to spread the fireworks out in the sky. So you've got some pointing to the left, some pointing to the right. And those angles are really important because as pyrotechnicians we want to say, you know, we identify a bit of the sky in our performance. We say we want an effect to appear there. We might want sometimes all at the same time. Sometimes we might go from left to right and then from right to left again. It's that variation that's really important. But the key with mortars is because you're firing a projectile, a large projectile, maybe to, you know, a couple of kilos, so a couple of bags of sugar in weight, up into the air, maybe to 150 meters. There's a huge force required, a huge pressure required. We can't have any recoil. If you think about, you know, sometimes in films you watch people firing a gun, they fire, you know, as they fire the gun it sort of recoils back. The tubes will do the same. And if the tube recoils, that takes away some of the kinetic energy from our projectile. We want all the energy to go into the projectile and get it as high as possible in the sky. If your tube moves, that takes away some of the energy, and so your firework doesn't go as high. It may not look as impressive in the sky as well.